Hello there, welcome to this podcast. I'm just going to go through a Chemistry 1 paper, higher paper, from start to finish, and this one is the 2013 paper, higher tier. First thing to notice is that you get your periodic table with the paper. Obviously this will be A4 on the day, on the big day. Right, so, first question gives you a hint about a clue about what the question's about. Hydrochloric acid. Electrolysis of hydrochloric acid produces chlorine and hydrogen. This is the experimental setup. Explain what is meant by electrolysis. So what is electrolysis? Electrolysis is breaking down of compounds, 1 mark, using electricity, 1 mark. Okay. Describe the test. So you've got chlorine. So you can get chlorine given off. It's damp blue litmus paper. Turns white. Ooh, spelled white wrong. Okay. Then chlorine is used in the manufacture of polymer. This is just again recall. You just need to know it. So what is name the polymer? So this is polychloroethene. Polychloroethene. So it will. Oh, I'm just looking here. Yeah, it'll accept PVC. That's fine. So if you just put PVC, you get the mark. Over here, dilute chloride silver nitrate to form silver chloride and nitric acid. Complete the sentence by putting the reaction produces silver chloride as a precipitate. In an equation, this should be shown as. So precipitate. What do we know about precipitates? Precipitates are solids coming out of solution. Okay, so it's just basically saying, do you know what these symbols mean? That's dissolved, that's a gas, that's a liquid, that's a solid. So as it comes out as precipitate, it's a solid coming out of solution. It is that solid there. So we've got some reactants here. Silver nitrate with dilute hydrochloric acid measured. After the reaction, the total mass was measured again. Data will compare them as before the reaction. There will be no change. No change. Do you like asking this question in loads of different ways? We've seen it before, haven't we? With 17 grams goes in, or given mass goes in, what comes out? It's just basically testing you. Do you recognise it? Mass is conserved during a reaction. What goes in must come out. It might be in different forms, but what goes in must come out. Write a balanced equation. So 2 marks for balancing equations. Reaction of silver nitrate plus hydrochloric acid. It's not giving you the formula for that, I expect you to know that. Gives you AgCl plus nitric acid. If you didn't know what nitric acid was, you could work it out by looking at the things you've used already. So, are they balanced? Yes, they are balanced. All the marks are for that one. So the only thing we've got to balance it is just being able to write. This is the R bit, isn't it? Putting that through. Turning over. Cracking. Always look at the top. Oh, was that on camera? That one's straight out of place. In the lab, the apparatus uses to crack large hydrocarbon molecules to form shorter hydrocarbons, and they've got the setup there for you. When the experiment is complete, there is danger that the water will rise up into the delivery tube, the hot tube. Right. So, what you need to look at is you need to look at the experiment setup. This is a really stupid question. When the experiment is complete, there is danger that water will rise up the delivery tube into the hot test tube. Now, what we used on ours was a valve. So you put a valve here, and that stops the water going back up this way, because you don't want it going back up that way, because if the water goes back up that way, it's going to get very hot very quickly, and it's going to turn to steam, it's going to cause all kinds of issues. So you're either removing the delivery tube once boiling, or after heating, or you attach a valve to the delivery tube. Right, so then we've got the actual equation for cracking. So again, this is just showing you a reaction, but just what the examiner's asking you is, do you get that what goes in must come out in some form? So if you've used 8 C's, so that means you've got 4 C's left, it's out of these two. H's wise, 18, this side, 26 there, the difference being 8, that means it's B. So unsaturated, you've got to get used to this, and spare bonds, they don't like you using it. Okay, so we are going to just go with saturated, unsaturated. Unsaturated contains a double bond, at least one double bond. Don't say it's not full up or it's got spare bonds. You just don't like it, so don't write it. Right, describe what you see in the test. So propane, propene are bubbled through separate samples of bromine. It's asking you, do you know how an alkane and alkene react with bromine? Of course we do. So bromine water goes from orange to clear in the presence of propene. Bromine water, so put water in that first one, stays orange in the presence of propane. In industry, long chain hydrocarbon molecules are cracked to form shorter. So explain why it's important. This is all about the demand. Okay, the demand for the shorter chains is higher. So shorter alkanes are more useful than longer alkanes, as they are in demand. And then you can talk about the alkanes forming plastics. Alkanes that are also produced from plastics, to polymers. Easy 2 marks there, people. So, as the questions go down, they're asking you here at the end, it's more demand than they are at the first. You get 1 mark, 1 mark, 1 mark on the left hand side, and here you're picking up more marks. So 8 marks for question 2. Turnover. Gases in our atmosphere now. So here we go. Centre of carbon dioxide today is, just recall this is, and you know of course it's less than 0.5%. Done that with each other so many times. Explain what caused centre of carbon dioxide to decrease. So why is carbon dioxide going down? Now there's 2 main reasons, and the first one is a lot of it got dissolved into the oceans, and you could put and trapped into carbonate rocks. That's 2 marks there, dissolved into oceans. But if you want to go down a different route, we talk about plants, so evolution of plants took CO2 in through, you guessed it, that term we all love, photosynthesis. Carbon dioxide and the gas in the atmosphere help to keep the Earth warm. State how these gases keep the Earth warm. So this is the greenhouse effect. This 1 mark. We're not writing a geography essay, okay? So we just need something like traps heat or reflects heat back to Earth. These are all 1 mark answers. Traps heat, reflects heat back to Earth. Okay, it's got nothing to do with the ozone layer whatsoever. Right, test. Describe the test to show that oxygen is a gas. Right then, this is the 3 tests, don't you? Chlorine, hydrogen, and oxygen. We've already asked about chlorine, now they're asking us about oxygen. Oxygen is a glowing splint, relights. Glowing relights. That's relit. What's a plonker? That is, of course. Right then, so again, as we go through the question, it's more wordy, more marks on for offer. So let's see. Magnesium, we did this in class. Magnesium reacts with oxygen to form magnesium oxide. Placed in the basin. The bell jar is placed at the top. So you've got this setup. What's going to happen? It says cooled, the water has risen. Explain why the water level has risen. So, you've got this magnesium. There's 20% oxygen in that bell jar. That 20% oxygen attaches, bonds with the magnesium. So that the space that was occupied by the oxygen is now, you can't have a vacuum in there, so that is then, the water level will rise by 20% because the oxygen isn't in this air anymore, it's attached, it's bonded to the magnesium. So that is why the water level's risen. So oxygen bonds with magnesium and the water level rises to occupy the space. You don't even need to put 20%. You can do if you want to show off, that's fine. But that's 1 mark there and 1 mark there. The water level rises to occupy the space the oxygen was in. Easy mark so far. Not massive issues at this moment in time. And how many marks are we through now? 11. We're halfway through the paper, so we're going to get close on 30 now. At the start of the experiment, the volume of the oxygen, volume of the air in the bell jar was 100 centimeters cubed. Assume that 21% is oxygen. Calculate the volume of gas that was present in the bell jar at the end of the experiment. Well, that's pretty easy, isn't it? Because it's nice, easy numbers to work with. If you're struggling, you can say, right, if it's 100, take the 0 off, and 21% of it, so that means 21% of it is oxygen, which is 21 centimeter cubed, which means 79 centimeter cubed must be other gases, but we are, and then you just put your 0 back on there. So that means that must have been that, and that must have been that. 790, bang. How's that one for you? Metal oxides react with acids to produce salts and water. Dilute sulfuric acid was added to magnesium oxide. State the name of the salt formed. So, metal, sulfuric, magnesium, sulfate. Not too many issues there either. Let's move on. Quite an easy question, that one. So now I'm talking about metals, aluminium. First real bit of data to analyse here. So let's do it and do it well. Drinks are often sold in cans. These cans are made of either of aluminium or of steel coated with tin. The table gives information about these 3 metallic substances. Use the table to give 2 right reasons why it could be more important to recycle tin than 2 reasons more important to recycle tin than aluminium or steel. Well, this cost is massive, and this is the second reason. Reason number one, reason number two. So the cost of tin is higher than the others, is higher than the other metals. Cost of tin is higher than aluminium and steel. Reason two is the amount of availability. Availability. Oh, come on. Availability. I'll spell this right in a minute, I swear. Availability of tin is less than aluminium and steel. The reaction of aluminium from its ore involves, right then, do we know how we get aluminium from its ores? So, if you're struggling, you've got to do it by elimination. You should know that heating with carbon, it doesn't work because aluminium is more reactive than carbon. Thermal decomposition, again, only works with the least reactive metals, with carbon, and then neutralisation is just talking about the rubbish. So by default it's reduction, but you are reducing it down. Okay, you're taking away its oxygen. Explain what you understand by the term alloy. So a definition, but it's not defined, it's explained, so you've got to talk about it. But ultimately, the definition of alloy is a mixture of at least two different metals. And then, this is a simple definition. Well, metals is not strictly true because you use carbon, don't you? But they're accepting metals, and they like using that definition, so let's stick with it. Right, so explain in terms of their structures why magnesium is stronger. Why magnesium is stronger than pure alloy. So this is an alloy. So why are alloys stronger than pure metals? Right, so aluminium atoms are in layers which slide over each other. Okay? However, by adding magnesium, these layers are disrupted, preventing them from sliding over each other. Full stop. In layers, 1 mark, slide over to 1 mark. Magnesium, these layers are disrupted, 1 mark, 1 mark. So I've got 4 marks with 3 there. But you're often going to do that. You're going to pick up more marks than available because you don't want to stop. You're not going to stop your sentence there, are you? You want to just thoroughly explain it.